Hello, assalamu alaikum everyone. So this video is all about introduction to quantum computing. Okay, so yeah, recently we can see like lots of quantum chips like from Google, IBM, and so on. Those are out there, and many people are assuming, and obviously the claims are like quantum computing can actually do the computation even the computers can't do in thousands or million years. So, and it's true, but not in every case. Okay, it's still not in the situation that we can apply it to every situation, every problem, and there are a lot of things. It's not like classical stuffs. Now, talking about this thing, like just assume or just remember that the classical bits are created by gates, right? It's basically the electric stuff, right? We are controlling that using the gates. But talking about the quantum computing is totally different. There are lots of ways we can create these qubits, like photonic, there are like superconducting qubits, there are a lot of stuffs. So we are basically dealing with components and so on. There are a lot of things. Even if you want to solve a problem, there are a lot of stuff. It's not like a normal problem, and so you can just create. There are a lot of things like ANSHAs, parameterized quantum circuit, and so on. You have to do. You have to deal with it. So still, currently, most of the things are in hybrid process. A lot of things are done in the classical computing, and a few of the things are done in the quantum chips. Okay, let's not talk about that. Let's just begin and let's talk about how these states and what are these basically. Okay, so talking about this, we have here is our quantum register or quantum state. Okay, so you might have heard of this thing like quantum state. So this is the quantum state we have, the quantum state. So here you can see that there's something like this icon, right? So this is basically called bracket. Okay, so this is like bra and cat. Okay, so these are the icons we do use in general. So you'll see that later on, not like this is the bracket, like here we can see like this is how we can represent like this is one, and again we can represent it like this. Okay, bra and cat. So this is how it works, bracket, and let it be. Now the thing is, this is basically our quantum, the values or the combinations we do have in the I, and Ci is the amplitude as a whole. So we'll learn about that from here. So if you just go a bit here, so you can see Ci, and C is basically part of complex number, right? And also from that we get the probability. So how can we get the probability? So this is basically the modulus square. Okay, and the summation of all of the amplitude, summation of the modulus square is actually 1. Okay, so these are the things, basically these are few laws of quantum mechanics and quantum computing which you have to abide by. But just a few things, but I just don't want to get deep into this topic. Let's start talking about some sort of gates. Okay, because classically we have binary bits and then we deal everything with gates, something like that. In quantum computing we have gates. So today we are basically going to know about 4 gates, and basically 4 different gates. One is X gate, another is or Z gate, another is control X, and another is controlled Z gate. Okay, great. Now talking about this. Okay, so you see, like as I mentioned earlier, we had something like I, right? So just this I has been turned to 0. So this is basically 0 qubit. Okay, 0. So something like, okay, assume that we have a 0 qubit, and you may say like, what is 0 qubit, what is 1 qubit, right? Just giving you an explanation. In binary we can have either 0 or 1. We have just 2 values, right? These are the binary bits. We can either have 0 or 1. In quantum computing we can have 0, 1, or both, the combination of both. There are a lot of things that can happen. Okay, so like that. Okay, so these are like there are a lot of quantum mechanics involved with it, so you can just learn about it. But I'm not going to get deep into these topics today. We're just going to learn about these things. So assuming that we have just 0 in quantum computing, which we can say as qubit, 0 qubit, okay. And if we actually move that through a X gate, we get this one. So it basically flips, right? Just like in classical computing, we have NOT gate, right? So this is the X gate. Okay, great. So something like that. It goes same for our 1 gate, right? Here you can see that in the 1 gate we have one qubit. If you just look into this one qubit, so if we pass it through X gate, we get 0. This is how it works, right? And another interesting factor in quantum computing is we can represent anything like in a combination manner. So what am I saying, right? You may say that. So for example, here you can see x2 alpha 000 and so on and so forth, right? That's interesting, right? So in quantum computing, just if you just look the previous example here, what did we write? Ci, and that's the qubit. So this alpha is actually meaning the Ci, right? The amplitude, right? And this is our qubit, right? So now you can understand, like, okay, we have seen this kind of architecture earlier, so it's something like quantum computing. But you may say, like, why there are 3, right? Why do we have here 3? Why do we have beta and so on? So just keep it simple. It's just normal stuff. Like if we compare this like 0, right? Just like that. We can just say that this is our Ci and this is our this one. So this is what we were creating qubit, right? And when we have the too many of that, you have to understand that basically here we have multiple qubits, and how are we organizing that? So if we want to understand this architecture, just if I want to make it simple, just let me take only this part and also this one. So what are we understanding from this one? Let's understand. We have x2, then we have alpha 0 0 0. Great. So what do we understand from here? Here we are understanding that it is basically some sort of, like, as we have seen, x is a gate, right? So it's related to an operation. So let me draw that so that you can understand that properly. So you can see there are 3 lines, that means, and there are three qubits. So the first, that means in the last row we have the 0th qubit, the middle one is 1th qubit, and last one is 2nd qubit. So 0 1 2. So this is something you have to understand, that in quantum computing this is pretty much tricky for folks who are like working with classical bit. It is pretty much tricky. So in that manner, again, what happens is 0 0 0, it might seem like this value is for qubit 0, this might be for qubit 1, this might be for qubit 2, but you are wrong. Or same goes for me. It is not. Basically this is qubit 0, that means this is qubit 0, and the value is obviously 0, and this is qubit 1 and this is qubit 2. So the value is 0 0, right? So if we for example, if I want to write something like this, let me just change the value so that you can understand like how this works. Okay, let's go for that. Let's assume that we are applying x to these two, like I will mention, but prior to that, let's just change it to 1 0 0. Great. Okay, we're applying x2 on 1 0 0. Now understand what's happening. Sorry, this is our qubit 0, this is our qubit 1, and this is our qubit 2. So what x2 means is, on the qubit 2 we are applying x gate. So on the qubit 2, where is the qubit 2? But prior to that, let's just put the value. Qubit 0 value is 0, qubit 1 value is 0, qubit 2 value is 1. So what we're saying is, on the qubit 2 we are applying x gate. That means we are applying x gate here. That means the value will flip and it should be now 0. That means 0 qubit, right? These are actually qubits. I just didn't draw it. Okay, these icons. And for others, we are not applying any gates. That means that should be pretty much like this, 0. Then let me just let me just move in a bit. So it should be 0 and it should be 0. And what we can do is, in quantum computing, what we do is we just combine all of them together. Again, we'll write that in this manner. You see, first will be qubit 2, second will be qubit 1, last will be qubit 0. So the qubit 2 value is 0, the middle q1 value is 0, q0 value is 0. This is actually 0. Great. So this is how it works, right? Now it should be pretty much easy for you to understand that. That is, this means qubit 2, this means qubit 1, this means qubit 0. And then if we just look into only this operation, just forget this one. What we can see is, just don't see, look into this, just focus on that. We want this x gate to be applied on this one, right? Qubit 2. So this 0 should be turned into 1, right? Let's see. Yes, isn't it, right? This turned into 1. But these two remained same, right? Isn't it? Yeah, because we didn't apply anything to these values, right? So this is how we can actually work with our our gates, right? Great. Then let's talk about Z gate. Okay, so let's talk about the Z gate. So in the Z gate, what Z does is, if like a 0 qubit is passed through Z gate, it keeps the values like as it is. But if 1 is passed through it, it changes the value to minus 1 qubit. Okay, here is the thing. So just focus on this one. Now you can do it on your own, right? Everything, like you can take this example. Okay, let's do it so that you understand, like, okay, we are right in every time. Okay, let's understand. Let's take this one, but again, not the whole. We are just going to try into Z0 and this one, like, because as we can see, there is a bracket. That means Z0 is applied to both of them. But we're just taking this example to understand this part. Okay, so Z0, and we are sorry, let me change the color so that we can make it differentiable later on. So Z0, and then we do it like beta 1 1 1. So as it is, so let's just say what it is. So this should be our q0, this should be our q1, and this is our q2. That's great. And we are saying, so let's just draw this gates. Okay, so first of all, just the lines. Okay, so it should be q2, this should be q1, this should be q0. Great. Now understand, what we are saying is Z gate should be applied to 0. So that means here we should have a Z gate, but for others we don't have. So as for q2 we don't have anything to do here, so we just do one thing, that is we just have the value 1, we just put it here 1, and then q1 we have the value 1, it should be put it here. But for this one, q0, it goes through Z, and we see, like, if we pass 1 through Z, it gives us -1, so it is -1. So yeah, everything is qubit for sure. Now we have to combine them together, right? So If we combine them together, again the format should be q2, q1, q0, right? So first one is 1, second one is 1, last one is 1. Great, but the minus is obviously outside, so this should be the result. Let's check if the result matches. Yes, it matches, right? Okay, by the way, this is plus. Okay, let me just remove this. Okay, this is plus and this turned into minus, right? So this is what we were looking into. And okay, let me just make it this line much bigger. Okay, great. Yes, I think you might not understand that. Like, let me just make it again. Just write this thing again. Just saying the first one is 1, second one is 1, the third one is -1. So obviously minus will be outside. So yeah, that is the portion we are looking into. We are interested, right? Isn't it? Yes, we are happy that we have been successful solving that. So we have successfully learned about two gates, X gates and Z gates. That's great. Now if we have to solve this one, like I'm giving you the assignment, like, okay, how to solve this one, you can do that, right? I hope you are going to solve this one, but I will also currently show you like how to solve that. Okay, so kindly pause this video and solve this one. And yeah, okay, I'm assuming that you have solved this one, and great. But let's see that if or how it should be solved. Okay, so as I mentioned, it is q2, it is q1, and it is q0. Like obviously it's not well written, but here you can see it's like written q2, q1, q0. That's great. And same goes for that. It is again q2, it is q1, and this is our q0. And again, as we mentioned earlier, that this is how the format is: q0, q1, q2. It's okay. So we are saying that this whole thing should be passed through this. So we will solve this in we can solve that in various manners, to be honest. Okay, we can solve that okay, so first of all, let's just look into let me just remove this so that you can understand. It's much more clearer. Okay, let's just go for this one. Okay, that means this one, this portion. Okay, let's go for this one. So first of all, so you see this is q2 value is 0, so we will keep it 0, and q1 value is 0, and q0 value is 0. Great. So first of all, we just pass it through everything. Okay, so what we can do, there are a few ways to solve the problems. Okay, we can individually actually solve the issues, like solve the gates, qubits, and pass them through the gates, or we can actually do it like step by step, like firstly solve this one. So we'll look into two ways. Okay, so first of all, let me just do it in this way, like every qubit, like individually we're doing that. Okay, let it be. So here you see this 0 is actually in this one, right? This 0. So, and this one is this one. Okay, so yeah, as supposed it is here. Now this q2 is supposed to go through the X gate. So, and you see the value is 0, so it will be 1, right? The value is 0, it should be 0. The value is 0, it should be 1, right? Great, we're done. Now we just combine them together and it should be 1, 0, 1, because q2 is here, q1 is here, and q0 is here. Great. So this is how it is, 1, 0, 1. Great, right? So let me just so we have got one answer. So for this one, we just got the answer should be 1, 0, 1. Great. Now just let's do for 1 on 1. So just removing that. So now it should be okay. My bad. Now it should be, obviously the values are same, so we can't see that much of difference, right? So 1 on 1. So this one should be here, and this one should be here, and this one should be here. So if we pass this one, we get 0. If we pass this one, we get -1. That's interesting, right? Because yeah, z as I mentioned earlier, this is how it works. And if we pass this one, we get 0. Great. So after that, we get this problem is solved. It should be minus beta 0 1 0, right? This 0 is here, this one is here, this 0 is here, and the minus came as it was plus earlier, so it is minus. So this should be the answer. Okay, so however you do, this should be the answer for our problem. Great. So this is how it can be done, right? This is like one way, like we manually go through everything, or we can just keep them compact and solve them together. But it's like it just depends on which process you like most. Okay, so if we just compact them together and solve this one, so now what we are going to do is we are going to just pass this whole thing individually one by one. Okay, firstly this one, this one, this one. Okay, so if we just pass this one here, pass this one, let me just show it. Pass the whole thing here. Okay, here, just avoid this one. This means qubit 2 operations, qubit 1 operation, qubit 0 operation. Okay, we are passing it here. So we are currently working on only with this one, step by step, but we have passed the whole thing, the whole stuff. The whole thing has been passed. Now understand what's happening. The thing is, so here we have alpha 0 0 0 plus beta 1 1 1. I don't know, like this space is very low. So okay, let me just okay, beta 1 1 1. Great. Now here's the thing, as we know this is the qubit 2 operation, so what will happen, only this, only, sorry, my bad, those are qubit 1, only the last ones are going to be impacted. These ones leftmost, okay, these are going to be impacted, like this one and this 0. Others are not going to be impacted, right? So what we are going to do, it should be, as we have 0 0 1, so it should be 1 0 0 and plus beta, it should be 0 1 1. Great. Yeah, this is what we are supposed to get, right? Now we are done with this one. Now we have to pass this one here. Okay, so if we pass this one, again what we see, this is a Q1 operation. That means in the middle one, only this will be changed or this will be impacted. So if you pass Z gate, if you pass 0 to Z gate, you know there is no change. If you pass 1, there is some change, right? So it should be 1 0 0 as it is, no change. But here we have minus because 0 1 1, because if we pass 1, it returns -1 qubit. Great. Now we have to pass this whole thing here, okay, through this one. So as we know, now it should be what we should working on, we should be working on this one. This is q0, 0 qubit. So you see we have 0, so it should be 1, and we have 1, that's, this should be 0, right? So yeah, great. So it should be 1 0 1, minus is minus, no problem, and 0 1, and should be 0. Only this was impacted, right? If you just look into that. Great. So done. So let's just see. We have no options. I just removed, I just deleted that. So let's just remind that, isn't this what we created earlier? Isn't this what we get earlier? So this is how it works. So whatever method actually you like, you can just go for that. But this is the mostly used one. Just everything, we just have these ones. And also this is the same thing we saw earlier, right? Remember, if we just add this thing, like let me just remove few stuff so that you can, these things are pretty much clear to you. Okay, so remember like we applied like x gate in qubit 2, so this can be written as x2. We applied z gate to qubit 1, so that means this can be written as z1, right? And we applied x on qubit 0, so that means this can be written as x0. So yeah, that was what we saw earlier in our gate operation, like in x and z. Like, so you can say like, okay, where did they come from? So this is where they come from, right? So this is how we can solve the issue. Let me check if we have 0 0 0, although these are not, these are all z gates. Okay, oh, I was trying to like see if we have the answer. Yeah, okay, again, if you just want to solve that manually, you can just check that. If we just do it quickly, like 0 0 1, so what we should have, 0 0 1, it should have been the earlier ones. It should have been like 1 0 1, right? Okay, I've just removed this one. So the answer is from here, the answer was actually 1 0 1 beta 0 1 0. Okay, let me just try to see like if that was the answer. So if we pass 0 0 0, we have from 0 we get 1, from 0 we get 0, from 0 we get 1. So 1 0 1, great. It is alpha, and just initially keeping it plus, then we also had like 1 1 1, so it should be 1 1 1, so passing 1 should be 0, 1 should be minus 1 qubit, and this 1 should be 0, so it should be beta, and this should be minus, and it should be 0 1 0. Let's see if they are the same. 1 0 1 0 1 0. Yes, exactly same, right? Now again, as I mentioned, but if you just individually go for every bit, it is going to be time consuming, and we have not yet explored the actually different gates like Hadamard. We haven't explored control gates. So yeah, here we go, Hadamard gate. So this is something called Hadamard gate, right? So this Hadamard gate has like, if we pass 0 to the Hadamard gate, it returns something like positive state. This one, if we pass 0, we get positive. If we pass 1, we get negative state. And you say like, what is this positive? And this is basically something that has been defined for the value of this. Okay, if we have this, if we have this, we know the actually this is what we are getting. We should be having 0 plus 1, this one. Now here you see, earlier we said that in the quantum computing we can have both of the values, like 0 and 1 both, right? Here you can see this quantum computing bit, basically this is what it is. Basically it is basically meaning we have, okay, so this is basically the CI, right? We have CI, and if you just follow, okay, let me just if we just use this is basically CI, right? These are both of the, we have the amplitude, right? And this is our qubit. So we are saying that we have the probability to have 0 qubit, and the probability, this is not the probability, this is the amplitude basically. Obviously the probability is 1 by root 2 square, so it should be 1 by 2, this is half. And also if we just do it, so this is again 1 by root 2 square, so it is half again. That means what we are saying is we have the probability to get 0, and the probability is basically half or 50%, and the probability to get 1 is again 50%, right? So yeah, this is what we are saying. This is basically meaning 50% probability, and this is again meaning 50% probability. So this is something we have in quantum computing, right? In classical computing we don't have that. So this is a state, this is meaning plus, which is meaning we can have 0 or 1 both, right? 50% chances for 0, 50% for 1. right? So yeah, if we pass this 0, we get +1, sorry, this plus state. But if we pass sorry, if we pass 1, we get minus, and in minus it is basically the minus sign here, nothing different. Okay, so again, same goes for that, and it is basically 50% chances for the 1 as well. You can just do it for yourself by yourself. Okay, great. So this is Hadamard, that's great. Now talking about the controlled NOT, that is something we have to or I have to actually draw the get. Okay, so let's do it. Let me look for it. Control, here you can see the control NOT. So this is 1 0, and this is not what we are meaning by 1 0. It's basically meaning qubit 1, it is meaning qubit 0. Okay, so this is how it works. Let's just explore this one. Let's move into this one and understand what's happening. So here you can see that C0 gate, as mentioned in the C0 gate, when we write this one, we have to mention this one. So this is a control bit, and it is so we are saying that the qubit 1 is the control bit and qubit 0 is the target bit. Okay, so that means depending on the bits on qubit on this or here, like maybe it can be 0 or 1, whatever it is, this should be impacted. Okay, so how it works? So if we have the value, for example, if we have the value, this one, for example, if we just take this one, what does this mean? This means this is q1 and this is q0. So we just put the value 0 0 here because this is what it is, and q1, and this is q0 it is, right? So let me just show like what's happening. So we have 0 bit and 0 bit right now, and basically we are doing this. So this is our qubit 1, this is our qubit 0. So we have said that C0 gate 1 0, which means this is our control, this is our target bit. So we are applying this gate, this is basically this one. So this can be, it is not mandatory that the architecture should be this one. It can happen that the architecture is like this. It can happen. So when this happens, we will say that this is C0 0 1. Okay, that means Q0 is the control bit and Q1 is the target. Okay, so it is basically it impacts the other qubit, right? Great. Now let's draw this one. Okay, let me just a bit. Great. Now what we are going to do is, now what happens, how C0 works. So C0, the rules for controlled NOT or C0 is that if the this is the control, okay, control, just for controlled, this means this is what that controls, and this is the target. Okay, so if the controlled bit, this this is not the value, this is meaning the qubit. So if the controlled qubit, this is the controlled qubit, this is basically this is meaning this q1, and controlled qubit, the value, this is 0. If the controlled qubit is 0, there is no impact on the result of q0. Okay, in this circumstances. So here you see this is 0, this should be 0, no problem. But this 0, if this is 0, and then there is no difference when this passes through this one, there should be 0, no problem. So you can see 0 0 0 0, no problem. When we change that to something like but when this one is like 1, this result actually flips. So this is what we will see right now. How are we going to see this one? This is interesting. So how we can see that is through another value. So let's check this one. This is actually the answer, but we just don't need to focus on this. So if we take this one 1 0, so as mentioned, 1 0, so this is our qubit 1, this is our qubit 0. So qubit 1 should be here and qubit 0 should be here. So the value of qubit 1 is 1, right? And the value of qubit 0 is 0 qubit, right? Great. As mentioned, if the value of qubit 1 is 1 qubit, uh, the value of qubit 0 should be flipped. And you see now, we are not focused on that, we are not focusing on that. So this should be flipped. That means it should be from it is 0 right now, so it will be flipped to 1. And as you see, like this 0 passes through this, so this is impacted, but there is nothing like here we don't have it, so it will be exactly 1 out here. And if we just compact this one, we get 1 1. Isn't this what we get here? Great, right? And this is exactly what we get here. So this is how it works. So this is how the control gate control NOT works. Another important factor is control NOT is actually the X gate, right? Control X, like, isn't it, right? You can see that if the value, like if the value of control, like the qubit 1 is 1, the value of qubit 0 has been flipped. And flipping works is basically flipping exactly what the X gate does, right? The X gate. So just for example, now let's work with this one. So it is our Q1, this is our Q0. So if you just look into here, Q1, Q0, and Q1 has the value 1 qubit, and Q0 has a value 1 qubit. So as mentioned, as we pass through this one, you see like this, that is not that much of any significance. One goes through this and one should be 1. This one is meaning basically Q1, okay? Just don't misunderstand that. Q1, Q0, okay? This one exactly. What's the value? So it passes through, it should be 1, no problem. But here is the issue, because as mentioned, 1 0, that means one is the control, one is controlling, one is the ruler, okay? So if the ruler or controller has the value 1, okay, we have the value 1, then the value of the target, this is the target, flips. As you can see, the control or control qubit is 1, so this should be flipped, right? So it will flip and it will become basically where it flips when it passes through this one, right? When it passes through this one, it flips and it becomes 0. So you see, like if we just make this compact, as mentioned, it should be Q1, Q0. So we write it like it is Q1, so it should be 1, Q0, it is 0, so 1 0. Isn't this exactly what we were learning? Yes, it is. So we have learned control NOT as well. Great. Now talking about CZ, control Z. As mentioned, we have learned by now X gate, Z gate, controlled NOT, or you can say controlled X, and basically it's control NOT, to be honest. And another is controlled Z, and this is pretty much interesting, okay? This rule is, now the control Z is pretty much interesting and it's pretty much different, to be honest. Now how it works is, earlier we learned that the control NOT, that if the control qubit is 0, there is no impact. If that is 1, then something, the thing is the value of Q0 flips. In control Z, what happens is, if that is the control qubit is 0, no problem. But if we have 1 here, the value in target is passed through Z, right? So it is actually the same, right? Isn't it? Just look into here, right? If we just look into the controlled NOT, actually, it is pretty much easy for us to understand the control Z, right? We can call it control Z as well, but control Z is something we use in the research field. Okay, just look into this. Okay, let's do it this one. But as we have 0, there is not going to be any difference, so let's just focus on this one again, no problem. So this means qubit 1, this means qubit 0. It is just meaning like the control bit and target bit, but it is not the value. The value is this one. The value of qubit 1 is Q1, the value of qubit 0 is 1. So we just put the value qubit 1, it should be 1 and 1. and this is again qubit 1 and qubit 0, meaning this is basically to indicate like which line it is, and it passes through this one, we get 1, and it passes through this one. As mentioned, if the controlled bit is 1, basically the target qubit flips. And how does it flip? We have learned that if a qubit is if qubit goes through x gate, it flips. So it's basically something like x, like the this qubit goes through this one and it flips to 0, right? So this is how it works, 1 0, and it becomes 1 0, no problem. Exactly this is what happens for control Z, but if you understand like that manner, so you have to understand like this, it is Z, and for example, if we take this one, and so we have exactly the same, we just have one, let me just better. So if we have 1, and if we have 1, that means this is q1, this is q0. So as we have 1 in the control qubit, then what happens is the qubit we have in target is passed through Z, and we know if we pass 1 through Z, what we get? We get -1. So this is nothing, this should be exactly same because there is nothing happening, but this is basically Z that is here, so this is why it should be -1. Okay, so if we just compress this one, we will have, as mentioned, it is something like q1 q0, right? So q1 value is 1 and q0 value is -1, so we'll keep 1 here and minus here, so it should be this one. Yes, exactly the same, right? So in general, you also can just to keep in mind, you can understand like, okay, when we have just 1 1, we just have -1 1, that's it. And other than that, the result doesn't change. But how it works, we have just understood how it works. Okay, great. Now let's talk about this example. So this is your homework. If you're watching this video, you can just practice this one and share with me the answer in the comment section. But you can pause that right now and actually work on that, but I will also show you how we can work on it. Okay, let's work on this together. Let me pick this one, so it's like we have both, and as we can see 1 0, so it will be better for us. Let's just use this one. So if we just use this one, let's understand what's happening. So there are two lines, right? In general, what happens is the qubits we actually place from last to first. Okay, so same, it should be 0 qubit 0 qubit 1. As we can see, we have just 2 qubits, and it is exactly 2 lines and 2 0. This is what it is meaning, and this one is meaning q1 for sure, and this one 0 is meaning q0, right? So let me just draw it differently. 1 0, right? This is our q1, this 0 is our q0. Great, that's great, right? Now so we have the value 1 out here, and we have the value 0 here, right? Okay, so there are several techniques we can look into to solve actually like complicated gates, but there is one technique that's pretty much very easy. Like if you just follow this one, it becomes pretty much easier for anyone. So we will just do that one. Okay, just simple as that. Just draw this one along with me, like we just did the H gate, and we have this one, and we have H again, Hadamard. Basically this is called Hadamard, and we know if we pass 0 through Hadamard, we get plus or positive state. Okay, and if we get past this one, we get a negative, which is minus this one, and this has some value. You'll see that when we are practicing. Okay, what we can do is, as we know, the values are like, let me just okay, let me just write 1 0. Okay, what we can do is, wherever there are changes, we can just create some part like artificial partitions, like these partitions. You can see this is basically Z gate. Okay, control Z. Okay, so you can understand what's happening here. So this is the difference, like, and this is another thing. if you work in classical, if you work with classical gates, you will see your teachers sometimes do make this kind of thing, so that it is easier for you to understand, like what happened here, and when it went to this change, what happened here, and so on. So let's just understand what's happening. Okay, so as mentioned that from this image, just forget these parts, okay, just focus on this part. Let's see what happens. What happens is, you see, like from this to this, just think like these never exist. So if you pass this one and it goes here, this is the output maybe, so it should be exactly this one, right? 1. And why can't I like write properly? Interesting. Okay, great, because there's nothing here, right? H, header Z, or whatever, there's nothing, right? So it should be passing through here to here, there's no problem. So in this point, the value of this is 1 qubit, no problem. But in this position, the value of 0, if it goes through here, what should be this? You know, like this should be this one, positive. So it should be something like this. Great. Now it has changed. Now, great. Now we will pass this one through this. But here is an interesting factor. From this positive or plus state, you can't understand like what is the value of 0, 1, because now it is control Z. So you have to understand like, okay, what is control Z, control Z, or what is this plus state meaning? We surely plus have 0 and 1 both. So what we can do is, as we have understood previously earlier, what we were doing, after we are done with the task, we can just compact these ones, and we can create something. So we can just compact this one and this. So how can we compact? Like as we saw, like it is basically Q1 Q0. So it was basically 1 0 earlier. So this is exactly what we are going to do, Q1 Q0. So Q1 value is 1, and this value is positive. But this is not how we write it, to be honest. How we are going to write it is, we can for sure, wherever or however we work, we can write it in this manner, no problem whatsoever. So for example, if we wanted to actually write it in this manner, like 2 brackets, so there is no problem, you can just write that. But in general, these are exactly the same. Okay, we can write it so that's what we are meaning. So there is no problem with this one. Now what we are understanding by this is, this means basically 1 by root 2 and 0 plus 1. Yeah, this is what this means, right? Now as we can see that, like there are like some sort of like these are multiplications, right? So it should be multiplicated here. Okay, great. So it should be something like 1 by root 2 will be keeping that as common, no problem. 1 by root 2 will keep that common. And you see, this is basically, this is not 1, this is the bracket part. Okay, so we have now 1 0 plus 1 1. Okay, great. So just to clarify, like this is what we just put, just keeping that common here, and 0 and 1 was there earlier. So that's it. So it is getting easier right now. How it is going to be easier for us? Let's just make it simple. Just one more line. I don't know what's happened. And it should be 1 0. Sorry. 1 0. Oh, okay, no problem. Sorry for that. Sometimes 1 0. Okay, and just giving it this one so that it's easier for you. And 1 1. Okay, great. So this is what we have in these positions. Okay, so you see, we started with 1 0, but now we have this one. Interesting, right? We initially had 1 0, but we now have value for 1 0 and 1 1. Basically these are the amplitude, not the probability. Probability is 50%, so we have 50% chance to get 1 0 and 1 1. That's interesting in quantum computing. Now we are going to pass this thing through here, but prior to that we have to again keep in mind that we just have 2 qubits, right? So let me clarify which are the qubits we have. So this is our q1, this is our q0, this is our q1, this is our q0. If you don't want to mix, you can exactly see this was our q1 from start, right? This was the, and this was actually the q0. This is the was the q0, this is the q1. We just broke it down to this one. So the same thing, no problem. Okay, q1, q0. Now let's focus on the z, control z gate. Okay, that's interesting. And we have to keep in mind that if you just look into this shortcut or manually look into that, we mentioned, so this means like here you see this is exactly the same thing. This is basically meaning the controlled is qubit 1 and the target is qubit 0. So if the controlled, you see the controlled is 1, right? And if that is 1, what we do? So if we just look into here, just forget this one. If we pass 1 0 through control Z, what we get? 1 0. Because you know, when we pass this portion 0 through Z, there is no difference. But we pass 1 through Z, we get -1. So the same thing. Here you can see as just for an example, just to give you the reminder. Let me just draw that again so that you understand. You just have this one, no problem. So if we have 1 0 and it passes through control Z, what happens is, as we have 1 here, right, this 0 is passed through Z, right, and Z or Z, Z gate, and there's no difference if we pass 0 through Z. So 0 is 1, so it should be 1 0, no problem, once it passes through this control Z. But if the value is 1 1, this 1 goes through Z gate and it flips to -1, right? That's interesting. And that is what we are going to get. For 1 1 we are going to get like for 1 1 we are going to get -1 1. So this is what happens. Like now if you just pass it through this one, so I just don't want to write this whole thing here or just a minute, because this is actually the compact of these two, right? So we understand if we just pass it through this control Z, just to make you understand by this look, like 1 root 2, then we had maybe 1 0 plus 1 1. If we just pass this through C's Z gate, that means that one, right? We will surely get 1 0, no problem with that doesn't change, but this changes. This should be 1 1. My drawing is so bad sometimes, like, because the pages are some the constraints. Okay, let me just write it here. 1 by root 2, and sometimes the lines becomes a constant for me. Okay, 1 0, and that portion becomes 1 1 for sure, minus, right, -1 1, right? This is what we learned just right now, right? So now after after the thing passes through this one, in this point we have the value, this is the value we have right now. Okay, again interestingly, this whole thing is passed through this one, like not the whole thing. You can just differentiate and do your own stuff. Like for example, if I would want to do it, what I would have done is I would have gone through this one. I might have done it in this manner, like this is no problem, like just 1 and 0, 1 and 1, no problem. And we can easily say like this is our qubit 1, this is our qubit 0, this is our qubit 1, this is our qubit 0, and we know from the circuit we can see that easily that this Hadamard is applied to qubit I would say to 0. Oh, I think this line was mistakenly added because never ever we do have this with Hadamard. Sorry for that. Okay, so yeah, we can do that for sure. So you can do that, but you have to keep in mind that this thing is also existing, right? So we can just we can just create it in this manner, maybe, because this was actually part of that, because like we can keep it with, like for example, we can keep it like this one. No problem with that, right? I'm so much okay, sorry for that issues we have. Okay, let me just draw it again so that you just understand. Okay, let me draw it here. So you can just make it different, but there are multiple ways. Basically, it's easy just if you just pass this through. But as I'm assuming you're a beginner, that's why I'm just breaking it down. We can write it like this, right? For sure, like individual qubits. Okay, this is our q1, this is our q0, this is our q1, this is our q0, or you can just write the qubit 1 here, and then the whole other stuffs out here. No problem. And exactly, these are all like qubit. These are our qubits, right? So this is our qubit. This one is our qubit 1. This whole thing is our part of our qubit 0. So you can assume that, but it is not good practice. What we can do, we can just understand that, okay, 1 0 1 1. We can just work with this one. If we just work with this one, it's pretty easy, because because we are just dividing this one, then we have to compact again. No, we don't need to go for these. It's easy. Obviously, you can do that, but it's pretty easy if we just apply through that one which we got right now, which we have right now. So 1 0 1 1, right? Let me just write it again so that you understand properly. Okay, it should be 1 0, it should be 1 1, right? Great. So we just pass it through the Hadamard, but as we know, the whole thing never goes through Hadamard. The only the because here you see, like the q0, actually the q0 is the q1, it goes through Hadamard, so only it will be applied to q0. So we have to be cautious, so we are going to change it, right? So if we just pass the whole thing through Hadamard gate, what we are going to get is, let me just write it down, 1 by root 2, no problem. We had 1, this 1, no problem, and this 0 turns to plus, right? This one, and just to meaning that this 0 has turned to this, and this 1 was exactly 1, and after that we had 1. This 1 is here, no problem, because it doesn't change. But this 0, like qubit 0, we had 1, this will turn to minus, right? So yeah, this is how it works, but actually this is not how we write it, to be honest. We'll just now break it down. We'll break it down because we know how to break it down, right? Okay, let's do it. So we'll break it down in the left portion so that you understand. Okay, so what we are going to do, or we can do it in here as well. Okay, so we have currently the value of like 1 and positive, and I guess it's minus. Yes, we have minus. So we have 1 and and minus. So this is our qubit, like the qubit 0 has turned to this and qubit 0 has turned to this, no problem with that. And our qubit 1 has not been touched, right? Because you know, our qubit 1 had nothing here, so it was exactly like qubit 1, but qubit 0 has been modified and it has been something like this one. positive, negative. So we again compact this one, or you can just assume that what is happening here, right? This one. Now we just break it down and we can easily get this one. Actually, this is the answer, no problem, we are done. But again, we can just break it down, no problem, right? 1 by root 2. So we break, first of all, we have 1, no problem, we are just not going to touch it, but we have to break it down, and it becomes 1 by root 2. And we have, again, now we have 0 plus, this is actually 1. Sorry, this is not 1, this is bracket 1. What am I saying, right? This is meaning the qubit 0, and again this is meaning our qubit 1. Done. This portion is done, right? This portion is done perfectly. Great. Now we go for this one, and we just write our first qubit 1, no problem here, and then we break it down, this one 1 by root 2, and we have 0, and this is what it is, we have minus here. Okay, we will have minus, this is the rule. And so we have broken it down, no problem with that whatsoever. So now we just have to multiply and so on. If we just multiply, let's just look for that, we get this one. So like we just don't need to, we just like if we just take the common, like this is one portion and this is one portion, so everywhere we have this one, so we just take it outside and it should be 1 by root 2, no problem. And then inside we'll have 1, it will be 1 will be multiplied to 0 and this, so we just write it down. We just write a second bracket, no problem with that. 1 0 and minus is pause plus 1. Great, right? So it should be like 1 by root 2 whole square, so it's like half, right? So half multiplication, okay, and we can just write it down, like we can now compact this one, we can make it 1 0, no problem with that. We can compact this one and we can write this to 1 1. Done. And we can write 1 0, and we can write it 1 1, or just make it first bracket, no problem. So as we are almost done, so what we see right now is, okay, let me just, I'm trying to, okay, great. So we see right now is 1 by like root 2 squared is 2, right? And then we have this one, you see this is positive 1 0, this is minus or negative 1 0, so we just this one, and we have 1 1 2 times, right? So it should be 2 1, right? So this eliminates, and we have this value 1 1. So this is our answer. So if it matches with you, congratulations, you have done a great job with us. So yeah, thank you so much, guys. If you have any questions with these gates and any circuits you are unable to solve, you are welcome to actually ask the questions in the comment section. And yeah, thank you so much for watching this video, and see you again in another video of our Quantum Mania. Yeah, thank you so much, see you soon.